Okay, S-series switch port troubleshooting. And first step, let's see the diagnosis tool. There are two things, display and log. We can use display interface command to check the information about the interface. Here we can see the physical port status is up or down. And from here, we can see the port mode, the port medium, port speed, or loopback, duplex, negotiation. By default, the automatic negotiation is enabled. And if we are using optical fiber, we can display transceiver verbose to check the information about the optical module. Here we can see the optical module type, and here the optical module wavelength. This is a transfer distance, transmission distance supported by the optical module. And here are the alarm about the optical module. And display log buffer. With this command, the historical data on the port can be collected using this command, or obtained from this file log.dblg file in this directory, cfcard log file, this directory. Then let's see some cases. The first one is optical port cannot be up after being connected. So let's see the troubleshooting procedure. First, we need to check whether the interface has been shut down. If we shut down it manually. Then we need to check the configurations on two ends. Next, check the optical module. Then check links. Finally, replace the optical module. Let's see a typical case. This is a network topology. A switch is connected to NE80E using 10 gigabit multimode fibers. There are two optical distribution frames, ODF. And after the network deployment is complete, the link cannot be up. So, based on the procedure, let's see the first step. Check whether the port has been shut down. Enter the interface view and display this interface, or display this. We can check the current state of the interface. Here is down. If the port status is administratively down, it means the port has been shut down manually. If it is only down, it means it's not shut down by people. Okay, next, check the configurations on two ends. Enter the interface view and display this. Here we can see the current state. They are down, and here is the speed. The rates at both ends are 10 gigabits, and negotiation disable. Here we should know that for Huawei, 10 gigabit port is first state is disabled, and for others, the negotiation mode is enabled. Automatic negotiation is enabled. Okay, next, step 3, we need to check the optical module. Use this command, display transceiver interface, this interface, and verbose. Here we can see the wavelength. the wavelength of a multi-mode optical module is 850 nanometers. The fibers used on the live network are also multi-mode fibers. And the transfer distance, transmission length of different fibers, from different fibers, the transmission distance are different. And here we should know two things. First one, the multi-mode fibers can be used together with single-mode optical modules. But a single-mode fiber can only be used with a single-mode optical module. And how to classify, how to distinguish them? A single-mode fiber is generally yellow, and a multi-mode fiber is generally orange. So it means the multi-mode fibers can be used with single-mode optical modules and multi-mode optical modules. But a single-mode fiber can only be used with a single-mode optical module. Okay, next. The multi-mode fibers introduce dispersion during transmission. Therefore, the transmission distance supported by an optical module depends on the bandwidth mode of fibers. The link failure may be caused by the incorrect fiber type. So the following table lists the transmission distance of a 10 GE optical module when different types of fibers are used. We can see here are optical fiber types, several types, and bandwidth mode. Here are the transmission distance. So all the fibers used are OM1 fibers with a transmission distance of 33 meters. However, the actual distance between the switch and NE80E is 65 meters, which is far greater than the fiber transmission distance. Therefore, the link cannot go up. If the failure cause cannot be located after the procedures, then we need to check the received optical power of the optical module and determine whether the link attenuation is in acceptable range. Here, the current receiver module, transceiver module is minus 4.4. The received optical power is this, which is in the acceptable range. We can see the acceptable range is from 1 is the high threshold, and minus 20 is the low threshold. Between minus 20 and 1, they are all acceptable. And these two values can be configured by the users. Next, check links. If we cannot locate the failure, we can go to the next step, check links. A link failure can cause the optical port to be down. You can connect two ports through a fiber to check whether the link is normal. For example, perform link physical loopback on the ports of NE80E and switch respectively to see if the fibers are okay. Step 5, if the fault persists, replace the optical module and fiber. Here is a note. For the optical modules, different companies, their optical modules may not be compatible. So for Huawei devices, Huawei switches and Huawei routers, if they want to connect with each other, we suggest to use Huawei certified optical modules. And if the failure cause cannot be located, now we need to contact Huawei technical support personnel. Next, electrical port works in half-duplex mode. Electrical port works in half-duplex mode. And the troubleshooting procedure. Few steps. First, check the port configurations on two ends. Then, check links. Here is the typical case. After two electrical ports are connected, one port works in half-duplex mode. We can use command display this. First enter the interface, then display this to check the information. Here we can see for this interface, the duplex mode is half-duplex. Then we need to check the port configurations on two ends. The check items could be negotiation mode, the speed, the duplex mode. The negotiation, it means auto negotiation mode of an interface. By default, is enable. If it enable, it indicates that the interface works in auto negotiation mode. If it disable, it indicates that the interface works in non-auto negotiation mode. So, to ensure that the two interfaces work in the same negotiation mode, we need to run the negotiation auto command in the interface view to enable auto negotiation on the interfaces. If the interfaces are still down, disable auto negotiation and forcibly set the same speed and duplex mode on the interfaces. Then, check the speed. The speed means the current rate of the interface. If the rates of the interfaces are different, run the speed command in the interface view to set the same rate on the two interfaces. Next, duplex. The duplex mode of the interface. In the duplex mode of the interfaces are different, run the duplex command in the interface view to set the same duplex mode on two interfaces. And these three items are the most important parameters of the interface. If one port is working in force mode and the other port is configured with auto negotiation, the port configured with auto negotiation works in half-duplex mode. And the port configurations are incorrect when an electrical port in auto negotiation mode is connected to an electrical port in forced mode. The auto negotiation port cannot receive the duplex status information from the peer. So if we enable auto negotiation on two sides, they will exchange the duplex status information. So if one side disable the auto negotiation, then he cannot send any information about this interface to the other side. So it sets, so the switch that enabled auto negotiation, it will set its own working status to half-duplex. Error packets or lost packets may occur on ports. So if the configurations are correct, go to step 2. For step 2, we need to check links. If two interfaces are connected by a twisted pair, check the following items. First, check the twisted pair status. We want the twisted pair works properly, but if a twisted pair is faulty, we need to replace it. Then check the twisted pair length. The twisted pair length doesn't exceed 100 meters. So 10, 100, or 1000 meters electrical interfaces use RG45 connectors and category 5 or higher twisted pairs. The maximum transmission distance of such cables is 100 meters. So the distance between two switches cannot longer than 100 meters. Next, electrical module. The two electrical modules are functioning properly. That is what we want. But if an electrical module fails, replace it. So after this, if the failure cause cannot be located, contact Huawei technical support personnel. Okay, let's see the next troubleshooting. Port status alternates between up and down. The procedure here: first, exclude the misoperations, then check the configurations and links. Then analyze log, check the peer device. Finally, contact Huawei technical support personnel. So here is a typical case. When two electrical ports are connected during device upgrade, the port status alternates between up and down. Here we can see the logs. This interface turned into up state, then turned into down, then up and down. So step 1, we need to exclude the misoperations. For example, incorrect command executions and network cable removal. If the fault is not caused by misoperations, go to step 2. Step 2, we need to check configurations and links. Ensure that no protection configuration such as shutdown has been performed on the ports. For electrical ports, check whether the network cable is correctly connected. For optical ports, check whether the fibers and optical modules are correctly installed. Remove and reconnect the network cable, fibers, or optical modules if possible. Step 3, analyze logs. So we need to view the up and down logs on ports and check whether the port status changes follow certain rules. Generally, there are 4 fault symptoms. The first one, multiple up and down logs are recorded for ports within a short period, for example, 60 seconds. The possible cause may be the peer device is restarting. Symptom 2. Two ports generate the up and down log at the same time. The possible cause could be two ports connect to the same device and an active or standby switchover occurs on the device. Symptom 3. The interval at which a port alternates between up and down is variable. So possible cause may be the peer device performs operations on the local port. Symptom 4. Ports alternate between up and down in different periods. and the interval between up and down states is equivalent or to or shorter than 1 second. So check whether the status flapping occurs on the local port or remote port. If the problem occurs on the local port, perform a loopback test on the local port and fix the problem on the local port. If the fault persists, contact the technical support. Okay, so before performing the loopback test, we need to remove all service reliance from the port to avoid impact the service. Step 4. Locate the port on the peer device. If the fault cannot be located on the local port, check the peer device. To suppress port status flapping, perform the following configurations. First one, carry down hold time 1000 or carrier up hold time 1000. If the port persists, contact the technical support. Okay, that's it. This lecture is about the